Welcome to EDU World Space.
Now we are given that we have a photon of energy 1.05 MeV striking an electron and producing two electrons and one positron, basically doing a pair production reaction. Now we are given that this scenario is not possible, and we want to ask why. So, well, at first glance, it might seem possible if we were to just naively look at what is the rest energy of the electron-positron pair that is required, and what is the energy required to produce this pair, right? So, looking at the mass energy for the electron, MEC square, multiply this by 2, it's actually 0.511 MeV multiplied by 2, which is just 1.02 MeV, which is smaller than the energy for the gamma, right? So this should be possible, but it's not. So the picture isn't that simple. So the important thing to note here is that our electron itself is stationary, and that the subsequent products are actually moving, right, with a certain velocity. And the reason why is because it has to conserve momentum. Our momentum at the initial stage is non-zero due to the photon itself having some momentum. So the final products must also have a momentum, and this is what actually prevents this reaction from taking place at just 1.02 MeV or even 1.05 MeV. And I want to find what is the exact energy that is required to do this process. So I'm going to start off with energy conservation. So that's the initial total energy must be equal to the final energy. So the total initial energy is energy of the gamma ray plus the rest energy of the electron. The final energy of all our particles is equals to 3 times. We are assuming that they are moving in the same particular direction, right, with the same velocity. And so their total energy is equals to gamma mc square. They have the same mass as well, right? So gamma is basically taking into account that they have kinetic energy as well as the rest energy. Next, we demand that the momentum must be conserved for the entire process. So that is, the initial momentum must be equal to the final momentum. Initial momentum is E gamma over C. Right, remember that energy of the gamma ray is equal to PC, momentum times C. So energy divided by C is the momentum of our photon. Energy of the photon must be equal to the final momentum of the system, which is 3 times of gamma mv. Right? Gamma mv is the momentum of our electrons. Now we are able to do some manipulation to these two equations to figure out what is our E gamma. So first off, what we want to do is we take equation 1 divided by 2. So on the right hand side, we can take away some of the common factors, right? So like the gamma, the tree, and the mass, and we are left with only just c square over v. Now we can simplify it further by multiplying or dividing both sides by c. And c over v, we can actually simplify this as just 1 over b, right? 1 over beta, where beta is equals to v over c. Right? This is a very common term for use, especially in Lorentz transformations, where we involve the square root of 1 minus v square over c square, and we can just write it as 1 minus beta square. Right? Moving on, we're going to use the equations again, but this time we're going to manipulate it differently. We're going to take equation 2, multiply that by c. This will give us E gamma equals to 3 gamma MeV times C. And then we're going to subtract it from equation 1. So take equation 1 minus this previous expression so that we can get rid of E gamma in our equation. Get 3 gamma MEC square minus 3 gamma MEVC. Now we can divide everything by MEC square, right? Mass of the electron divided by NC squared, so just the rest energy of the electron. We divide everything throughout by that, we get 3 gamma minus 3 gamma times V over C. It's basically 3 gamma, 1 minus beta. Now substituting the actual formula for gamma, that is 1 over square root of 1 minus beta square. We can now actually solve for our beta. So one of the methods that you can use is by putting the 1 minus beta into this equation, into the square root, right? That's 1 minus beta square. Then we factorize out 1 minus beta, 1 plus beta. So from here you can cancel out one of the factor, 1 minus beta. And then we're going to square both sides. So we get 1 equals to 9 times 1 minus beta over 1 plus beta. Bring the factor over. And we get beta to be 0.8. Now we can substitute this into our previous equation over here. Right, since we have found that beta is actually 0.8, so E gamma from here we can finally solve for what is E gamma by substituting this the rest energy 0.511 MeV. E gamma is actually 2.04 MeV, which is greater than the 1.05 MeV that was given for our photon, right? And so the energy required is higher than the 1.05 MeV, and therefore the reaction cannot proceed with just 1.05 MeV photon.